Consider quadratic equation ax square plus bx plus c is equal to 0, where a, b, c are any real numbers and a is not equal to 0. So consider this quadratic equation. Can we divide both sides of this equation by a? Simply divide it by a. Ax squared divided by a plus bx. Every term is being divided by a. C by a equal to 0 by a. I mean, this term can be written, this equation can be written as x squared. You can easily see this a and a gets cancelled. X squared plus b by a times x plus c by a, and 0 by a, 0 divided by any number is always 0. You divide 0 by any number, you're getting 0 only. So our quadratic equation has been written in this form, where the coefficient of the first term is 1. Next, we want to change this in the form of whole square, and we will use the formula a plus b whole square. See, the formula of a plus b whole square is equal to a square plus 2ab and plus b square. We knew this formula already. So as we see, if we want to write this in whole square, a plus b whole square type, so what we will do, we will simply write this as first term is a square, which is fine, x squared, a is x, right, plus 2ab. Actually 2a would be x only, and b would be half of this term, half of coefficient of x. Half of coefficient of x is how much? Half of coefficient of x is b by a, so we will write b by 2a. So 2ab. Now if you look carefully, here this 2 and 2 gets cancelled. Actually this term is same as b by ax. What we are saying is this term b by ax and this term is same. This term and this term is same. Now the next term is a square plus 2ab. We would like to have that b square also, right? In this term, a square plus 2ab plus b square, so that we could use a plus b whole square formula. So what we are going to do is we are going to add this coefficient b by 2a squared, and we are going to subtract same number. Any real number added and the same number subtracted is not making any difference, and the last term c by a will also be there, and then this equal to 0. So when you are adding same number and you are subtracting also same number, it did not affect our equation. But you see this one, a plus a square plus 2ab plus b square. This value can be written as a plus b whole square, where a is x and b is b by 2a. So we can write it as x plus b by 2a whole square. Okay, and then this one is minus b square. We'll square this and we'll square 2a also, which becomes 4a square, and plus c by a is equal to 0, isn't it? Now what we want to do is, we have made the perfect square here. We'll keep that to the left, and the rest of the terms we are transposing to right. So this will imply, x plus b by 2a whole square is equal to this b square by 4a square becomes positive, going to right, and then minus c by a. Now we will simply take LCM on the right hand side, and this thing can be written as 4a square, I think. LCM 4a square, isn't it? and then this will be b square minus 4ac. Did you understand how this is happening? If not, see, since this is 4a square, this is 4a square in denominator, you want 4a square here also, so you multiply it by 4a. And if you multiply by 4a, you will multiply by 4a up also. So what do you get? This means you get b square by 4a square minus 4ac over 4a square. Then when you take LCM 4a square and the numerator terms come as it is. So you get this. Yes. If x plus b by 2a whole square is this, can we find x plus b by 2a will be what? We can take the square root on both sides. And we have this term here, b square minus 4ac. Okay, on the right side divided by 4a square. As we can see, we can easily take a square root of the denominator and the numerator will remain as it is. So we have plus minus also. Whenever we take a square root, we will use plus minus. And then this means x plus b by 2a, x plus b by 2a is equal to, let's write plus minus as it is. Let us write numerator separate, which is b square minus 4ac. Since we can find the square root of denominator, so this we write as 2a. Square root of 4a square is 2a, and we can say x plus b by a is equal to plus minus this. Okay, so what is x? X would be minus b by 2a. This goes to right, and plus minus square root of b square minus 4ac, b square minus 4ac divided by 2a. Now we can take again LCM and we can write them together. So we get x is equal to minus b plus minus square root of b square minus 4ac, and that divided by 2a. So these will be the roots of quadratic equation. We can use this formula directly when we have to find roots using quadratic equation. Now this means we have got two roots, minus b plus root b square minus 4ac by 2a, and minus b. Let's write them. So we can write, we got finally the two roots of x. X would be minus b plus square root b square minus 4ac divided by 2a, comma, and then we also have minus b minus, so one time we take minus b square minus 4ac by 2a. So these two values of x will be roots of the given quadratic equation, or they will be the solution of the given quadratic equation. Now look, as we can see here, the solution of the quadratic equation, whether there is solution possible or whether we are getting equal or we are getting different answers. For that, we have this term b square minus 4ac in the numerator you see, that determines whether the roots are equal or they are unequal or they are even exist or not. So because this determines the roots of equation, we say this discriminant. So discriminant. Now this discriminant would be b square minus 4ac. We call it b square minus 4ac. We'll simply write it by d, and which is d is equal to b square minus 4ac. So this discriminant is represented by capital D, which is b square minus 4ac. Now, depending on the value of discriminant will be the roots of quadratic equation. Now, what we are saying is, if discriminant is see whatever the discriminant we have found, whether either that would be 0, three things can happen. We will say our discriminant can be 0, discriminant can be greater than 0, or discriminant can be less than 0. Now we'll consider all these three cases one by one. So what happens when d is 0? When d is 0, your roots would be x is equal to, the formula was this, no? Minus b plus minus under root d over 2a. So this is the formula. And now if d is 0, that means this part is 0. This part over here becomes 0. So we'll get x is equal to just one value. X is equal to minus b over 2a. That's the situation when we say we have real and equal roots. Okay, so what we are going to write is, we will say here if d is equal to 0, we will say real and equal. Both root will be equal roots. And if d is greater than 0, consider the same formula again. We have x is equal to minus b plus minus square root d over 2a. Now if d is positive, we have some number over here, whatever the number is. So one time we are adding it and the second time we are subtracting it. So we are obviously getting two different roots. So that's very obvious and pretty obvious that if d is greater than 0, we will have a real and distinct root. Real and distinct roots, real and distinct solutions. And this situation can also happen when d is less than 0. If d is less than 0, you in the formula you have square root d. Can you tell me the square root of some negative number, say negative 100? Square root of negative number is not real. I mean, you cannot find a real number whose square will be minus 100. Can you find some number? Consider. Suppose you say, okay, let me see minus 10. So minus 10 into minus 10 will become minus 100, not 100, plus 100, yes? So you cannot find a number whose square is minus 100. So we cannot find a number whose square is minus 100, because we learned that the square of a number cannot, real number cannot be negative. Okay, so for that reason, we will say in this case, in case number 3, we will have no real roots. No real roots.